Hello everyone, today we continue learning Python and today I'll show you how to use multiple inheritance in Python. So let's start. But before we start that video, I recommend you subscribing to my Telegram channel. You will find lots of materials, modules, libraries, examples and tasks on Python in my Telegram channel. Also, I post all the announcements there, so if you want to understand what will happen to the channel in the near future, you can go here. And I respond to comments much faster than I do it on YouTube. So subscribe to my Telegram channel, link in the description down below. First of all, what is multiple inheritance? And if you don't know object-oriented programming, then you should not watch my channel, because I use it all the times and Python is about object-oriented programming. Everything is an object, everything is a class. Okay, so first of all, learn about classes and then come back to that video. What is multiple inheritance? You know that in Python you have a simple inheritance from one class. So for example, class A as ancestor and then class B as children, or as a child, as a child. And B from A. We inherit B from class A. So we get all the methods, all the public methods. I will not talk about underscores today because I have lots of information about them. We get all methods from our class A in our class B. And if I'll create an object B, so A equal, that's not how it works, object equals B, print object.x, what will happen? We'll receive 10, because we have that x in our parent, in our class A. I can override methods and variables in my children classes, in my child classes, I don't really know, in my child B, but in children classes, yeah. What I can do, I can override the value of x as 20, and now when we call b from object x, we'll receive 20 because of that, because I overrided my variable x. And we can do the same with methods. Now what I want to do, I want to create another class C that inherits from A, and we have x as 30, for example, x at 30, okay. And I want to create another class, a lot of classes, class D, which inherits from C, and dramatic pause, B. So we inherit from two classes, C and B. And what will happen to our variable x? I don't know. Nobody knows. Well, actually, I know. If we overwrite our variable x in our ancestor D, or in our child D, for example, x as 1000, and we'll call object equals D, parenthesis, object.x. We'll call it, we'll receive 1000, because we overrided it in the child D. But what if I'll put pass? So we have not overridden our x yet, or we don't really need to override our x at all, because we have that x in C and in B classes, and we have that x in A class. So what value will we receive when we call D object.x? So we'll call D.x. What we'll receive? We'll receive the value from C or from B or even from A. Well, actually we'll receive the value as what? As 30. As you can see, 30. Why do we even receive that value, and why we have no errors as we do it in C++, as far as I know? Oh yeah, don't blame me in the comments. I forgot C++ a year ago. So what Python does? Python uses MRO. MRO, or method resolution order. Method resolution order. And that it's an algorithm that helps us to identify what class should we get, from what class should we get our methods and variables from. For example, in our case we have D child, and the D child wants to get X property or variable. I say variable because why not? Variables. We get X variable, and we go to D class. We don't have overridden variable inside of it, and because of that we need to go to our ancestors. But how we choose what ancestor? We need to go first. Actually, you see the order right here. So first of all, we go to C. We go to C, class C, and if we have that variable x in here, we just get that value. But what if we don't have that variable? So for example, pass. We have not overridden that variable inside of C. Then we'll go to the second class, which is B. B, if we have that variable, again, we just return the value. But if we don't have, we just return pass, or we just go to the next class, okay? So pass, we don't have that variable overridden in B and C. And what we need to do, we need to go to their ancestor. We need to go to A. Yeah, and if we have that variable in A, then we receive that value, so 10. But if we don't have that variable anywhere, we receive an error. So let's run and we receive an error, because that's how classes work. So again, what we need to do, we go to C, to B, and then to A. Actually, I can put A right here, but that's worthless, because we have that class A inside of C and B. We don't need to put it right here, but actually we will not receive an error, but actually we can break method resolution order, and I'll show you how. So yeah, that's it. We go to C, to B, and then to A. Now, how to get that method resolution order in Python? What we need to do is we don't need to create an object, but we need to call D, so the name of our class, and then .mro. So MRO is a class method. So it's attached to your class, not to an object of your class. Like that. DMRO, let's run, and as you can see, we receive a list of classes. So that list shows you how your classes are executed, when we need to get a value or a method. As you can see, the first class here is just your class, so D class, because if we have that method inside of, or method of variable inside of D, we just need to get that variable. Then goes C, so C class, the first class inside of parentheses in our D. Then goes B class, the second class, and then we go to A. But what is class object? Class object is a special class in Python, and every class in Python inherits from object. Why? So if you don't understand, we cannot see that, but implicitly we inherit from object. Okay, why do we do that? Because object, it's the most base type, and it has useful functions inside of it. So as you can see, delete attribute, dir, equal, format, get attribute. Let's go right here and you will see the function everybody knows. Init. So init is a constructor or init function in Python, okay? And if you want to use init in your object, so when your object is created, init is called. Init, let's go print, A is born. Like that. When I call D, as you can see, A is born. So we get that init method from class object, and we just simply override it inside of A. And and that's pretty useful in Python, because we have lots of things we can override from object, and we can control all the objects using that object class. That's pretty useful, and I like that idea. But what will happen if we will not have that method inside of, or let's call it again, we will not have that method init inside of any class? The old algorithm of Python worked like that. We go to C, we go to C, then we go to ancestor of C, to A, we go to object, then we go to B, to A, to object. I think you can see a pretty big problem with that algorithm, with the old algorithm of Python. So we can visit one object multiple times, and we don't need to do that because Python is pretty slow, and if we use old algorithm of MRO, so method resolution order, we would make it even slower, and that's a problem. We have one rule in MRO: every class appears once. Every class appears once. So if you have already visited a class, you don't need to do that again. And that's how it works. So, and because of that, I said that we don't need to put a right here, because that's worthless. But I think you understand now what is method resolution order. Method resolution order, or MRO, shows how to get values and attributes from your classes. That's it. But actually we can break that method resolution order. So again, I said that every class should appear only once, or must appear only once. But it's better to say that. What will happen if I put A right here? So A, C, B. Actually, we receive an error, so let's run. As you can see, type error cannot create a consistent method resolution order, or MRO. For bases, base is just a parent of, or ancestor of A, C, B. Why does it happen? Because when we need to go to A, we just simply go to A, we go to object, then when we need to go to C, what happens? We go to C, and as you can see, we have A. We need to go to A again, And because of that rule that every class should appear only once, Python knows that we don't need to do that, and we don't really need because we have that class A inside of C. And let's run now. As you can see, the same result, but now our code works. So yeah, actually that's it. So again, method resolution order helps you to identify how to get values, attributes, variables, methods, functions from your ancestors, from your parents, from your bases. Like and subscribe. MRO. Good luck.